We got more cider. Here you go.
Okay.
Welcome back to Starlit. We still haven't finished our avocado toast, but we are drinking a new cider. It's called Cosmic Current. It is actually local to Oregon from Two Towns Cider House. Everybody supports small businesses. And today, I have a question for Nova about baryonic matter. There's dark matter, and then there's baryonic matter, right?
Mm-hmm.
Everything we can see is baryonic matter, right?
Right.
Okay. Baryons must be like protons, neutrons, electrons.
You were good until electrons.
Okay, so electrons, we can't see them. They're dark matter. Electrons are dark matter, right?
I know where you're going with this. No, electrons are not dark matter. We have no idea what dark matter is. If it's made of a particle, we don't know what that particle is like. We have a lot of theories, no observational evidence as to its properties beyond the fact that it's mass that exists.
In the standard model, the stuff we know about, we got our fermions and our bosons, right?
Right. So fermions are things like protons, electrons, neutrons, things you're familiar with, as well as some stuff that you're not. Basically, anything that's made of quarks or what we call leptons, which are electrons and their siblings. Bosons are things like photons.
Yep.
The photon doesn't have any mass, so it's not being added into this.
So it doesn't matter. Literally, it's not matter.
It did matter in the early universe for the universe's expansion, but now it's kind of irrelevant.
Yeah, but then, the radiation-dominated universe ended because of cosmic Doppler effect, so it doesn't matter anymore.
Don't call it Doppler effect, but yes.
Don't call it Doppler effect?
No, because it's...
Redshifting?
Yeah, the cosmological redshift is not the same as the Doppler effect.
Bear with me.
No.
Squid with me? Dog with me?
Doppler effect. If a thing is moving toward or away from you and emitting waves, the frequency of that wave will change. In particular, if something is moving toward you, its wavelength is going to be squished, and so it's going to have a higher frequency.
Mm-hmm.
If it's moving away from you, that wavelength is going to get stretched, and so it's going to be a lower frequency. Mm-hmm. You can hear this when a car passes by, and that's why it appears to have a higher pitch, followed by a lower pitch when it passes.
No.
This also works for light. Light that is emitted by a source moving toward you will appear bluer, or shorter wavelengths. Light from a source moving away will appear redder, longer wavelengths.
This is how we know the universe is expanding. This is how we tell how far something away is.
The reason it's not technically the same is because cosmological redshift, or the fact that objects that are further away appear to be moving away from us and also happen to be shifted in wavelength in the redder direction, it's not really because these objects are actually moving away from us through space.
Well, isn't
space itself
Oh.
is expanding. And that's what's stretching out the wavelength of light. Yes, it's very similar, and the equations are quite similar as well.
Potato. I never thought to think of space as a thing that was moving.
I'm a graduate student at the University of Chicago, which really likes its cosmology, and that means that a lot of people get really annoyed.
Just Kelvin timeline this nonsense and say it's a different equation. But it's basically the same equation.
It's the same equation, kind of.
This is somebody else's starlit pet
peeve. Dark matter
Yep.
is basically mass that we know exists because of how it interacts gravitationally. But it doesn't emit light, it doesn't seem to interact with light. The only reason we know it's there is because we can track the way that baryonic matter, or luminous matter, basically matter that emits and interacts with light, the stuff that we know and love, like protons, we can see how that stuff moves and it's moving in a way that makes it very clear that there's extra mass there that we cannot see.
So what I'm hearing is that all fermions are baryonic matter.
Yes.
Because you got
The
your
issue
baryons,
is
your leptons.
Everything that's not dark matter is, according to astronomers, referred to as baryonic matter.
Yeah,
The
it
issue
should
is that
be fermionic matter.
not all baryonic matter is in fact baryons.
But all baryonic matter is
You're probably
fermions.
confusing people because at this point, we've never actually explained what a baryon is. Baryon is any particle that is made up of 3 quarks.
So protons and neutrons.
Yep.
For example, mesons. They are baryonic matter, but they're not baryons because they only got 2 quarks.
Mm-hmm. Electrons are what we call leptons. There's another on for you. They're not the same because electrons are a fundamental particle. They're not made up of quarks. Now, the reason we call it baryonic matter is because when we're astronomers talking about baryonic matter, or luminous matter is a name that I actually prefer. It's matter that interacts with light.
Well,
versus
luminous matter versus dark matter, that makes sense.
Yes. And so when we're talking about the difference between those two, we're typically concerned with how much mass is in either one. In particular, we know that there's a lot more mass in dark matter than there is in luminous matter.
Are you calling leptons a rounding error? Is this where this is going?
Yes, because the thing is, most of the mass in baryonic matter is held in protons and some neutrons.
So are you saying that because they're small, electrons don't matter?
They are matter, but no, they don't really matter, at least in the mass budget. They matter for other effects, keeping the universe neutral.
Yeah, that, like, magnetism.
Right. But they matter for their charge, not for their mass.
It's really hard to keep track of all of this, as, like, we've just struggled with. Why make it harder? Why not say that luminous matter is just fermionic matter? Therefore, we know it's all fermions.
Because
Why say baryonic matter, but then include a bunch of things that aren't baryons? It's counterintuitive and mean for someone who really struggles with remembering stuff.
Because astronomers are lazy. Someone refers to something in a paper one time, it becomes the canonical paper in the field, and everyone uses that name. For example, I study something called cosmic rays. Cosmic rays aren't rays, they're particles. But we still call them cosmic rays because when people first discovered them, they didn't know what they were. They thought they were rays coming from space, hence the name, cosmic rays. We later learned they were particles, but the name had stuck and it was too late. Cheers.
Is this why population 3 stars are a thing?
Yeah.
This pisses me off. So, there are 3 generations of stars, according to scientists, that we think. We haven't actually seen too many pop 1 stars. Or too many pop 3 stars.
Yeah.
Okay.
Our sun is a pop 1 star.
Yeah. So our sun, it's a pop 1 star.
That's the current generation
That's
of
the
stars.
3rd generation of stars. The 2nd generation of stars, that's pop 2 stars. Okay, that makes sense. But then the 1st generation of stars, that's pop 3 stars. So what about the 4th generation of stars? Are you going to go pop 0? Are you going to have pop -1?
We'll
or
all
we
be
all
dead.
be dead?
Stars live for...
Plan ahead, Rebecca. What about our children? It's going to be like 5-6 billion years, isn't it?
Yeah, by which point we won't even be living on this planet anymore, if at all.
Yeah, humanity's going to
Because-
have evolved.
Well,
into
more
something
importantly,
else.
by definition, when the next generation of stars comes into play, our generation of stars will be dying out, which means our sun will be dying.
Our sun's
So
going to
Earth
go...
will no longer...
Yeah, our
be
sun's
livable.
going to go gas giant and literally envelop the Earth. Like, Earth is going to be eaten by our red giant sun. Maybe we'll have colonized another solar system. Honestly, humanity isn't going to last 5 billion years. Like, that's just not how evolution works.
Yeah, that'd be really optimistic.
Yeah, and the idea that humans, like, get to another planet is also really optimistic. I'd love to see it. I'd love a Star Trek universe. Thank you for answering my question about baryonic matter. Thank you to Cosmic Current for being quite delicious. Astra out.
Nova out. By the way, this cider is a metal.
Ad Astra, to the stars, to the stars.